darn it. Okay, got it. All right, so H naught O sub I equals E sub I, H1 O sub I is not equal to E sub I, and like Shashank said, the claim is the first one because there's no difference. So the claim is H naught. Degrees of freedom, you said it was 4 minus 1 times 2 minus 1, so it's 3. And so that's our critical value. There we go. And then E sub I, so E sub expected value of 1, 1. This first spot, the first row, first column, is the row total times the column total divided by the grand total. And then 2, 4, the last one, is the second row, the fourth column. So again, you're going to take your row total times your column total divided by your grand total. Like I said, 5 years ago, they had to find all of those expected values and then do them all by hand. Blank minus blank, squared divided by blank, plus, all the way through. Right, so this is a lot easier. I'm just going to make you, but you have to just prove to me you know how to do parts of it. I'm not going to make you do the grunt work or just calculate these two, right? And then on the 11.1, you've shown me you know how to do the O sub I minus E sub I squared, so you've shown me that part there. So as long as you show me the pieces, then we're fine. So then you're going to go to stat, test, I-squared test. And Shashank, what did you get for that? What did you do? Explain to me what you did.
I-squared test?
Yeah. Like what did you...
So I wrote down like the x squared and the p.
Okay, but how did you... What did you do? How did you... What were the steps you did on your calculator?
Oh, to get there?
Uh-huh.
Stat test and then the x2 test.
Of what? There's something that goes in here. What'd you put there?
Oh. L3.
No. Matrix A.
Matrix A.
Right, so then you put these things here into matrix A, or did you just copy off Michaela?
No, that's what I did.
Okay, so this is not L3, this is matrix A.
Yeah.
Okay, and what did you get for your chi-squared?
I got
Michaela got
14.15.
Don't grab her paper and look at it to give you the answer, and then your p-value was. Then why don't you grab her paper and pull over and look at it?
I forgot I had it.
Okay, and your p-value is equal to. Was it your don't.
0.0027.
0.00271.
71.
Okay, great. All right, so Michaela, where does the chi-squared go?
In the critical region on the right side.
Great. And then what did you get for step 4?
So I got reject O.
Reject H naught.
Sorry.
Reject H naught. Great. And then step 5, you got what?
We have enough evidence to reject the claim that there's no difference in the proportion of people in each economic group who were very happy.
Reject claim. What was your claim again? What did you say? That again?
There's no difference
Uh-huh.
in the proportion of people in each economic group who were very happy.
Mm-hmm. Good. Perfect. Difference in what did you say? In proportion?
The proportion of people in each economic group who were very happy.
Perfect. All right. Good. Everybody on board?
Yep.
Makes sense. You could have shortened it. Yeah, I guess like you could get away saying enough evidence to reject the claim that there's no difference in the proportion of happiness between economic groups. That's probably the minimum that you could probably write if you want to write less words. But what you said was good. All right. Good. The next one we are going to do later, problem 3. Instead, we're going to grab our 11.3 one-way ANOVA. And Shashank, go ahead and read for me.
11.3. When comparing more than two means, the t-test should not be used. This section introduces the method of one-way analysis of variance, which is used for tests of hypotheses that 3 or more population means are all equal. Because the calculations are very complicated, we emphasize the interpretation of results obtained by using technology. The hardest part of ANOVA will be identifying the problem with ANOVA.
Problem as ANOVA. Great. So again, if we're comparing two means, we would just use a two-sample t-test. If we're comparing more than two means, 3 or more, then we're going to need to use ANOVA. Good. Dennis, go ahead and read the next slide.
Requirements. The population from which the samples were obtained must be normally or approximately normally distributed. Want me to keep going?
Yes.
2. The samples must be independent of one another. 3. The variances of the population must be equal.
Great. Here is the hypothesis step. H naught is that the means are equal. So mean 1 equals mean 2 equals mean 3 for however many means you have. H1 then would be at least one differs. That's all you gotta say, at least one differs. You can't say they're all different, but at least one differs.
So you have to do that.
So you can't say that mean 1 doesn't equal mean 2 doesn't equal mean 3 because mean 1 might equal mean 2. Just you don't know which one's different. Just one of them is not the same. What was that? Is that making sense?
Yeah.
Okay, so Charmaine, go ahead and read.
If there is no difference in the means, the between group.
Oh, actually, let me explain something to you first. So here we have, say we have kindergartners and their heights. So they're like in this range here, right? We have 6th graders and their heights. They're in this range here. We have seniors in high school and their heights. They're in this range here. So so we have what we call a between group variance. So between the groups, these 3 groups, the variance between these 3 groups. Everybody kind of follow that?
Oh.
And then we have within group variance. So within this group, within this group, within this group. Good? So we're saying that within the groups, this amount of variance and that amount of variance and that amount of variance should be roughly the same. But within the groups, we have this different variance going on. So if this variance is much bigger, the between group variance is much bigger than the within group variances, then the means aren't the same. But say we have seniors from California, seniors from Oregon, and seniors from Florida. Then their within group variances are going to be roughly the same as their between group variances. You guys kind of see that?
Mm.
So then we would say that, okay, the means are likely to be the same. So go ahead and read this part here.
If there is no difference in the means, the between group variance will be approximately equal to the within group variance. Do not reject null hypothesis. However, when the means differ significantly, the between group variance will be much larger than the within group variance. So we reject null hypothesis. Since variances are being compared, this procedure is called analysis of variance.
Right. Analysis and variance, VA. Here's a test set for a one-way ANOVA, F. It's equal to the variance between samples. I might also call that the between group variance, or the divided by the variance within samples, which I may also call the within group variance. I will give you those things along with other nonsensical stuff like alpha and n and other things just to throw you off, and I'll ask you to compute the F from there, right? two things divided by each other. P5. Here is a key concept. Haley, go ahead and read.
Understand that a small p-value such as 0.05 or less leads to rejection of the null hypothesis of equal means. With a large p-value such as greater than 0.05 fail to reject the null hypothesis of equal means.
Great. So what we're going to be looking at here is rather than give you yet another table, because you have enough tables at this point,
We need chairs instead.
we're going to just look at p-values. So this is the opposite. Usually we've been looking at critical values. So the further away from zero, the bigger you are, you're going to reject the null hypothesis, right? This is the opposite. This is p-values. So remember, p-value is our guideline for unusual. What's our guideline for unusual typically? 5%. So if you're 5% or less, you're unusual. If your probability of occurring is 5% or less, you're unusual, reject the null hypothesis. So this is the opposite. If your p-value is small, 5% or alpha or less, we're going to reject the null hypothesis. Everybody understand that? So it's the totally complete different way of doing it than the critical value way. This is the other way. So if you have a small p-value, you're going to reject the null hypothesis. Because remember, the p-value is the probability of your sample occurring. So if the probability of your sample occurring is really unlikely, then you'd say, oh, wait, Ms. Young, your deck is not a regular deck. You have a fixed deck. You guys remember that? Because our probability is really unlikely. So that's what we're going to be looking at. Comparing p-values here. So it's kind of a mental switch for you guys. So we're going to test our null hypothesis. We're going to use a TI 83 or 84. Find the p-value from the display. If the p-value is less than or equal to alpha, we're going to reject the null hypothesis. If the p-value is greater than alpha, we are going to fail to reject the null hypothesis. Make sense?
Yes.
Very straightforward. Please note that if there's sufficient evidence to reject the claim, you can't say which one is different. Just at least one of them is different. You don't know. You can't determine which one it is. So if you want to do that, then you'd have to do a series of two-sample t-tests. All right, here's an example. Bunch of IQs based upon whether people have low levels of lead in their blood. Here's that first sample. Or maybe they have medium levels of lead in their blood. Or they have high lead levels in their blood. So here are three samples, three means. I'm going to have a mean from each of these. You guys see how my data is all numbers, right? So these are going to be means. Speaking of which, chapter 11.1 and 11.2, what we've been doing with these chi-squared stuff, those are proportions, right? Those are things in categories, right? Proportion in each category. 11.3 is means. So we're comparing different means to each other. So here we have this data. We're going to find the means of it and them and compare the variances. How many means do we have?
3.
3. Great. So H naught is mean 1 equals mean 2 equals mean 3. H1 is at least one of the means differs. At least one differs. Step 2. What's alpha? 0.05. Done. That's it. Step 3. We're going to use technology.
Ooh,
So,
technologies.
yeah. The one we're going to use is going to be the TI 8384. It's going to tell us our F value and our P value. So here the F is 4.07 and our P value is 0.0195. My alpha is 0.05. So I want you guys to take 5 seconds and decide whether or not we're going to reject H naught or not reject H naught. Silently to yourself. And talk to your neighbors about it. Okay, so what do you guys think? Reject or not reject?
Reject.
Reject. My p-value is 0.0195. Is that 5% or less?
Yes.
Yes, we're going to reject H naught. It's unusual. Everybody got that?
Yes.
Okay, good. So here, because p-value is less than the significance level, we'll reject the null hypothesis. So there is sufficient evidence that the three samples, or you can say that the means differ. That's all you have to say. So there's no claim, there's no support or reject. It's just enough evidence or not enough evidence that the means differ. That's it. Very straightforward, super easy. The simplest thing we're going to do in all of chapter 7 through 11 is this ANOVA. Because it's very complicated, we're just going to touch on the surface a little bit and just make it a very quick, basic covering of it. So those of you who eventually take psychology, I think it's 25, then you'll need to know how to do this test, which is just this. Okay? You gotta make sure you get that. All right, here is an example. We will do this one together.
All of this.
Get out your calculators, you'll need them. A researcher wants to know if there is a difference in the fuel economy between small cars, sedans, and luxury vehicles. Alpha's 0.05. Test the claim that there's no difference among the means. So, first step. H naught is what?
Mean 1 equals mean 2 equals mean 3.
Great. How come it's not on U4?
Because there's only 3.
There's only 3 lists. Everybody got that? Please note this. That looks like it sort of could be a table, but see how there's only categories across the top? So it can't be a table, because a table should have categories along the side and the top. So everybody good with that part?
Yeah.
All right. Good. And then H1 would be,
At least one difference.
At
yep,
least.
at least one differs. One differs.
That's our claim.
That's our claim, yep. Oh no, our claim is that there's no difference. Well, it doesn't really matter. We don't care about claims at this point. That's how easy this was. We don't even worry about the claims right now.
Yeah, great.
Step 2. Alpha equals 0.05. Done. That's it. No, just that section. Step 3. Find our test stat. So this is how you do it. L1, L2, L3. Let me know where you put those. And then you're going to do stat, test, ANOVA of L1, L2, L3. Those should have commas between them, but no worries. Everybody on board?
Yes.
So then I'm going to go to my calculator. Find my calculator. Okay, and I'm going to go to stat, edit, and I can put these into the lists. So 36, 44, 34, 35, 43, 35, 30, 29, 40, 29, 25, oops, 20, 25 and 24. Okay, then double check. Make sure that your lists are correct, because if they're not, you are SOL and you will have no idea that you are.
What is that?
I don't know. Ask
So, what
And
does that mean?
mine look good. Everybody here with me?
Yes.
So I'm going to go to stat, test, arrow up, because it's the very last one, ANOVA. Enter. I need list 1, second L1, comma, right above the 7, second L2, comma, second L3. Enter. And that gives me my F value and my P value. Everybody see that?
Yes.
Again, I'll show you one more time. Stat, test, up to, go arrow up, because it's the last one, ANOVA, enter, second L1, comma, second L2, comma, second L3, enter. Okay, so then I have my F value is 4.833, and my P value is 0.0375. Okay, so this is how we do our test. Step 4. Am I going to reject H naught or not reject H naught?
Reject.
Yep, reject H naught. There's no picture, so I have to say why.
Because.
My P value 0.0375 is less than 0.05. Good?
What?
That's alpha.
We can't see it.
Oh, sorry. I'm so sorry.
There you go.
So write them in. Reject H naught. My P value 0.0375 is less than 0.05. If you get confused about which way this goes, just write the words out. Is less than. That's totally fine. Yeah.
What is the F for?
F is the F stat. So it would be this. It's their test stat. So just write it down because you should know how to find that and understand that it's important to this problem. Even though we're not going to actually use it, you may use it in the future, especially if you take that psych class, whatever that class is that uses it. So it's good just to identify. That's the equivalent of like the chi-squared or the R or the T or the Z that the test stat we found before. And then our last thing is going to be enough evidence. We rejected H naught. And this is really easy. To say the means differ. So you're either going to say enough evidence or not enough evidence, depending on whether or not rejected H naught, and this is always going to be the same, to say the means differ. Good? Super simple, super straightforward, yes? Okay. Go do your next lab problem. Let me show you something. So again, take a look at it. Maybe. See how this looks like it could be a matrix? You guys see this?
Yes.
Right? It could be 6 rows and 3 columns, but there's only categories across the top, not categories along the side. So it can't be a matrix. That matrix problem has to have categories across the top and the side. This is lists. These are 3 lists. A list will only have them on either the top or the side. It could be a sideways list. Okay, good deal. All right.